In this lesson, we're going to go over Unit 4, Acquisition 3, which is drawing Lewis structures of covalent compounds. So a covalent compound is formed from a group of non-metals that are sharing electrons. So in covalent bonding, atoms share valence electrons in order to complete the octet. So that prefix co means shared. Like if you're a co-captain, you're sharing those captain responsibilities. And valent is for valence electrons. So covalent literally means shared valence electrons. An example of a covalently bonded molecule would be diatomic chlorine. Group of nonmetals bonded together. So chlorine has 7 valence electrons. And we know that chlorine wants to follow the octet rule. It wants 8 valence electrons. So if each of these chlorine atoms share one of their unpaired electrons, they can each have 8. So the chlorine on the left has 8 valence electrons, 7 of its own, the one that it shares. Same thing on the right. This chlorine has 7 of its own valence electrons, plus the one that it shares. When we are doing these Lewis structures, shared pairs of electrons represent what we call a bond, a covalent bond. And is shown with a line or like a dash. So rather than representing my shared pair of electrons like I have in this first example, the way that I would draw a Lewis structure of diatomic chlorine is I'm going to represent that bond with like a line or a dash connecting my atoms. Since I have one bond or one line, we call that a single bond. And that single bond represents 2 shared electrons, just like we see here. 1, 2, 2 shared electrons. We could also have a double bond. So if we had 2 lines connecting our atoms, we would call that a double bond. Each bond represents 2 shared electrons, so a double bond would be 4 shared electrons. And we could also have triple bonds. A triple bond would represent 6 shared electrons. 2 electrons per bond times your 3 bonds gives me 6 shared electrons. So these Lewis structures are going to be much more involved than ionic compounds. We are not drawing any arrows. Ionic compounds, we would draw arrows to represent the transfer of electrons. We don't have a transfer of electrons. We are sharing electrons. So I'm going to do like a 2-column notes. I'm going to do the steps down the left-hand side, and then we'll do water as our example down the right. So step number 1, the first thing we want to do is count the total number of valence electrons in the compound. Total number for the entire compound. So in water, in H2O, I have two hydrogens. Hydrogen is in group 1, so 1 valence electron. Based on my formula, I have 1 oxygen. Oxygen is in group 6. We have a total of 8 valence electrons to place. Step number 2. Determine the central atom. Two tips to help you figure out the center atom. If carbon's in the compound, it's always central. If carbon is in the compound, it always goes in the center. Carbon is in group 4, it has 4 valence electrons. If carbon has 4 unpaired electrons, it could form 4 bonds. It makes a really nice center atom. Well, what if carbon's not in the formula, like with H2O? Then the atom there is only one of goes in the center. So what I mean by that, if we look at water, water's H2O. There is only 1 oxygen. Oxygen is going to go in the center, and we are going to surround oxygen by the 2 hydrogens. Step 3. We are going to start by drawing single bonds. Draw single bonds to the center atom. Always start with single bonds. So again, I have oxygen in the middle, I have the hydrogens surrounding it. I'm going to start by drawing single bonds to that central atom. Step 4. We are going to place all remaining electrons on the most electronegative atom as lone pairs. So remember back in step 1, we calculated the number of electrons. We calculated 8 valence electrons. Now that's going to come into play. We have a total of 8 valence electrons. Remember that each single bond represents a shared pair of electrons. So this bond represents 2 electrons, this bond represents 2 more electrons. So I have 4 bonding electrons. That means I have 4 left over to place. We want to place the remaining electrons on the most electronegative atom first. Looking at my resource packet, oxygen has an electronegativity value of 3.4, hydrogen is 2.1. Oxygen is more electronegative, and we're going to place them as a pair. 1, 2, 3, 4. Step 5 is a step we don't always have to do. It depends on the molecule that we're drawing the Lewis structure for. Step 5 is to turn lone pairs into double or triple bonds if necessary. So again, this isn't a step we always have to do. It depends on the molecule. We only do this if necessary for every atom to complete its octet. So we don't have to do this with water. Look at oxygen. Remember, each bond represents 2 electrons. So oxygen has 2 4 bonding electrons, 5, 6, 7, 8. Oxygen has 8 valence electrons. It's following the octet rule. Hydrogen is an exception. Hydrogen is happy with only 2 electrons. This hydrogen has 2 electrons in its shared pair. This hydrogen has 2 electrons in its shared pair. Everything is happy, so water is good. Let's look at an example where we would have to go on to this optional step 5. Let's say I had sulfur trioxide. So step 1, we need to calculate the number of electrons. Based on my formula, I have 1 sulfur. Sulfur is in group 6, so it has 6 valence electrons. In my formula, I have 3 oxygens. Oxygen is also in group 6. So I have a total of 24 valence electrons to place. Step 2, determine the central atom. Whichever atom there is only 1 of will go in the center. The remaining atoms will be surrounded by it. So I'm going to put sulfur in the middle and spread those oxygens out around sulfur. Step 3, draw single bonds to the center atom. Step 4, we need to calculate the remaining electrons. Each bonding pair represents 2 electrons. So I have 2, 4, 6 bonding electrons. That means we have 18 remaining electrons to place. We are going to place them on the most electronegative atom first. Oxygen 3.4, sulfur 2.5. Oxygen is more electronegative, and we're going to place them as pairs. I have 18 of them to place. So 2, 4, 6, 8, 10, 12, 14, 16, 18. So now let's look at our molecule. The oxygens are really good. Oxygen has 2, 4, 6, 8 electrons. Remember, each bond is 2 electrons. 2, 4, 6, 8. 2, 4, 6, 8. But sulfur only has 2, 4, 6 electrons. We're out of electrons. I don't have any other electrons to place, but sulfur isn't following the octet rule. So this is where the step 5 comes in. Turn lone pairs into double or triple bonds in order for every atom to complete its octet. You can pick any pair you want. I'm just going to pick this pair. And let's turn it into a double bond, and let's see what that does. So now sulfur is double bonded to oxygen. I'm not going to write these electrons because these electrons are now a shared pair. But I am going to write the rest of them. 1, 2, 3, 4. I didn't touch these two oxygens, so I'm going to leave those alone. So now, does everything follow the octet rule? My first oxygen, 2, 4, 6, 8. Good. Second oxygen, 2, 4, 6, 8. Good. Remember, each shared pair is 2 electrons. 2, 4, 6, 8. This oxygen is good. Sulfur, 2, 4, 6, 8. Everything is following the octet rule. Your other check is you should only have 24 electrons total. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Make sure you didn't draw more electrons than 24. All right, let's do one more example. We'll do a few more examples in tomorrow's lecture, but let's just do one more for today. Step 1, calculate the number of valence electrons. Hydrogen is in group 1. It has 1 valence electron. Carbon, group 4. 4 valence electrons. Nitrogen, group 5. 5 valence electrons. So I have a total of 10 valence electrons to place. Remember we said if there's only one of an atom, it goes in the center. Well, I have 1 hydrogen, I have 1 carbon, I have 1 nitrogen. Which one's going to go in the center? So that's where you have to remember that other little rule. If carbon's in the compound, it always goes in the center. So I'll put carbon in the center. We'll put hydrogen and nitrogen around the outside. Always start by adding single bonds to the central atom. Each single bond represents 2 bonding electrons. 2, 4. That means we're going to have 6 remaining electrons to place. Looking at my electronegativity table. Carbon 2.5, nitrogen 3.04. Nitrogen is more electronegative. I'm going to place them as pairs of electrons. 2, 4, 6. I placed all 6 remaining electrons. Nitrogen right now is good. It has 2, 4, 6, 8 electrons. Hydrogen has its 2 electrons, so it's happy. But carbon only has 2, 4 electrons. It's not following the octet rule. So let's take a pair of electrons and let's turn it into a bond. Now, are we good? Hydrogen still has its 2 electrons, which is what it wants. Nitrogen still has 2, 4, 6, 8 electrons, so nitrogen is good. But how many electrons does carbon have? 2, 4, 6. Carbon still doesn't follow the octet rule. So what we can do is take another pair of electrons and let's turn that into a triple bond. Now let's check again. Does everything follow the octet rule? Hydrogen, 2 shared electrons. It's good. Carbon has 4 bonds. 2, 4, 6, 8 electrons. So it's good. Nitrogen, 2, 4, 6, 8 electrons. so it's good. You know you're done when every atom in the molecule follows the octet rule. Remember, atoms want 8 valence electrons. Our exception would be hydrogen, which is happy with 2.